Okay, in this chapter, we are going to learn the association rule. So this is the first technique in the data mining that we will learn. First, we will learn about the basic concepts, and we will check what is the frequent item set mining methods, and there are some pattern evaluation methods that we will learn together. So what is frequent pattern analysis? We usually use the term market basket analysis. Market means 시장. So you go to market, you go to supermarket, you go to hypermarket, you can go to the convenience stores, you will buy something and you will put it into the basket. We call this is the basket. Okay. If you go to the supermarket, the market analyst will think which items are frequently purchased together by customers. If you are the customer one, okay, you can check, okay, the items are milk, bread, and cereal. The other customer two, they bought milk, bread, sugar, and eggs. Customer three, they bought milk, bread, and butter. Customer N, they bought sugar and eggs. So, what items are frequently purchased together? If you look at this one, maybe it is easy to see that milk and bread, because milk and bread appears in 3 customers. But if there are 100 customers, if there are 1 million customers, then you need to learn some techniques to get the numbers. What is frequent pattern analysis? They call it frequent pattern. Frequent pattern means a pattern. A pattern is a set of items, or it can be subsequences, or it can be substructures that occurs frequently in a data set. So the idea has been proposed first by those 3 guys in 1993. So it's very old techniques. And we will learn those 2, which is the frequent item set and the other is association rule. What is the motivation? The motivation is to find the inherent regularities in data. Inherent, something that is important, something that is interesting to extract from the data. Let's say I want to know what products were often purchased together. So if you go to the supermarket, sometimes you can see milk and bread, pang, uyu, kanchi, which also. Why you can do that? Because they have the data. People may buy milk and they will also buy bread. Maybe you can also analyze about the electronic items. What are the subsequent purchases after buying a PC? PC is the personal computer. Maybe after you buy personal computer, you will buy a printer. After you buy printers, you will buy a new keyboard. After you buy a keyboard, you will buy a new webcam, and so on. So there will be a sequence, and you can check what is the association between those items. If you are in the biology, you will see the DNA. In DNA, you can see the sequence of DNA or the sequence of protein, and you can check whether some DNA some patterns of DNA is sensitive to the new drug or not. Or can we automatically classify web documents? So the classification in the web documents, usually we will see the patterns of the words. So there are many applications: basket data analysis, cross marketing, catalog design, sale campaign analysis. We can use this as the web log or clickstream, and we can also do the DNA sequence analysis. So it is a big question why we need to use this frequent pattern mining. Because sometimes it is not easy to find the intrinsic. The intrinsic means some like hidden. And you need to find the important property. So this hidden or this intrinsic, you can get it from the frequent pattern. It is the foundation for many essential data mining tasks. So this is the association. Yeah, if you can find the frequent pattern, you can do association. And you can check the correlation. And sometimes you can check the causality. You can see the sequential, you can see the structural patterns. And this frequent pattern, it is the first pattern analysis toward the spatio-temporal. You still remember spatio-temporal? Spatio. Spatio means space. So space usually it is related with the location when you have the x and y, the latitude and longitude. We call it the spatio. Temporal. It is about the temporal. It's about the time. The spatio-temporal means the space with regard to the time. So, for example, you can see the CCTV. If you watch the CCTV in Seoul City, you will see the spatio-temporal in which location, whether there are traffic or not. So you can also see this kind of frequent pattern. Multimedia, time series, stream data. So we need to use the frequent pattern before we do further analysis on this. And later we can do with the classification, and we can also use the cluster analysis. So there are many applications for this frequent pattern mining. So let's see the basic concept about this frequent patterns. When you buy something from the mart, if you buy something from the supermarket, you will have the transaction ID. The transaction ID is the receipt that you get, your sujan. Okay. So one receipt contains many items. So the transaction ID, let's say this is the transaction ID 10. The person who did this transaction, he bought bread and milk. The person who bought in the transaction ID 20, he bought bread, diaper, beer, and eggs. The person who in the transaction ID 30, he bought milk, diaper, beer, and coke. The TID 40, the person bought bread, milk, diaper, beer, and so on. The TID 50, beer, bread, milk, diaper, and coke. So we have 5 transactions, or we can say, yeah, we have 5 receipts. The first concept is the item set. Item set means it is a collection of one or more items. It can be one or n items. Let's say I have a milk, bread, diaper, and it is in the curly braces. Okay, then this one is 3 items in one item set. We call K. K is any integer that represent the number of items in the item set. So if the K equals to 1, then there will be 1 item. If the K equals to 2, then there will be 2 items. If the K equals to 3, then there will be 3 items. Let's see this one. We can check the frequent pattern when the K equals to 1. When the K equals to 1, so we can check for every single item. Bread. How many bread? 1, 2, 3, 4. How many milk? 1, 2, 3, 4. So we put 4. How many Coke? Okay, we have 1 and 2. So we will check all the frequency. If we have K equals to 2, so it means we want to get the 2 items. It means the 2 items should available in the transaction. For example, bread and milk. Bread and milk. Okay, and then we have bread and milk. And then we have bread and milk. So there are 3. What about if we have K equals to 3? So it means there are 3 items. Bread, milk, diaper. We have 2, so it's not. We have bread, milk, diaper. Bread, milk, diaper. Okay, there are 2. Okay. So we will count for every of the items until the maximum of K that we have in the data. Let's say we have 4. Well, we can use K equals to 4 to check the items. So we need to understand also the concept of the support. We call absolute support or the support count. The support count means the frequency of the occurrence of an item set. So you already see from the previous table, we can see that the occurrence of milk, bread, and diaper, we have 2. So because this is the support. We can measure the relative support. It is the fraction of the transaction that contains an item set. Or we can say this is the probability that a transaction contains X. So X is the item set. So I know that the S, okay, S means the support. And I would like to check the milk, bread, and diaper. As we learned from the previous table, the bread, milk, diaper. Bread, milk, diaper. So we have 2 out of 5. So we have 2 out of 5 transactions. The frequent item set means it is the item set whose support, the support is greater than or equal to a minimum support threshold. So if I have 2 divided by 4, let's say I have the minimum support is 0.5. Then this is not satisfied because the minimum support is 0.5 and this one is 0.4. Okay. Then it is not frequent item set. So you need to find the minimum support. You need to find the support that is greater than or equal to 0.5. That's the meaning by the frequent pattern. When we deal with this association rule, it means we want to check the association. This association rule means I have the X and I have Y. S, it means the support. And C, it is the confidence. Okay. It is the implication expression of the form X association with Y. So this symbol means association, where X and Y are item set. Okay, so this is an item set. This is another item set. For example, this one, milk, diaper, and then association with beer. It means that if someone bought milk and diaper, how many or how is the probability that the person will buy beer? So it comes to two different rule evaluation metrics. The first is S, which is the support that we already learned before. It is the fraction of transaction that contain both X and Y. So we want to check all of this. So we call this is the support. And the confidence means how often items in Y, appear in transaction that contain X. So this is the formula. So for every support, it will be divided by the T, the number of the transaction. But for every confidence, it will be divided by the number of X or the support of X. So let's see this kind of rule. Okay. Maybe let's just use this example. I want to know if the milk and diaper in the X. So if someone bought milk and diaper, how is the probability that he or she will buy beer? Based on the support, we will check the count. Milk, diaper, beer. We have 2. And then we have the number of transactions is 5. So the support is 0.4. What about confidence? The confidence means I would like to check the count of milk, diaper, and beer. We have 2. Okay. Milk, diaper, beer. Milk, diaper, beer. Oh, sorry, this is not right. Sorry. Milk, diaper, beer. Milk, diaper, beer. There are 2. Okay. And then I want to know if someone bought milk and diaper, he or she will also buy beer. So I want to check if the person bought milk and diaper, he also buy beer. And what we can get here is the support count for this milk diaper beer, milk diaper beer, milk diaper beer. There are two. And the support of milk and diaper, milk diaper, milk diaper, milk diaper. There are three. So it means for the person who bought milk and diaper, he or she will buy beer is 67%, because there are three transactions contains milk and diaper, and there are only two that contain milk, diaper, and beer. So I have a confidence that 67% this product will be bought. So let's put a number. I have the minimum support is 50%, or yeah, you can say this is 0.5. And the minimum confidence is 50% also, 0.5. And you can calculate this one. What is the frequent pattern? As you know, when k equals to 1, you can check. When k equals to 2, you can check. And when k equals to 3, you can check. And you need to satisfy this threshold. If you have 1, 2, 3, 4, 5, we have 5 transactions. And if the minimum support is 0.5, then it means the frequency or the count should be higher than or equal to 2.5. Okay, why it is 2.5? Because we have 5 transactions and we want to get only the 50% from these 5 transactions. So 50% from the 5 is 2.5. So every count which is higher than 2.5, it will be in the frequent pattern. So beer, we have 3. 1, 2, 3. Okay, it is in the frequent pattern. Bread equals to 4. 1, 2, 3, 4. Okay, this one is in the frequent pattern. It is when the k equals to 1. What about if k equals to 2? K equals to 2. Then we have beer and diaper. So there are 3 occurrences. Okay. So how we can calculate the support and the confidence? The support and the confidence, if the support, you can use the k equals to 1. But in order to calculate the confidence, you need to start from the k equals to 2. Here I want to check if someone bought beer, he or she will buy diaper. Beer, diaper, beer, diaper, beer, diaper. Okay, based on the formula, beer, diaper, beer, diaper, beer, diaper. So there are 3 beer, diaper. And then I want to check how many person who buy only beer. So we have 3. Then it is 100% for the confidence. But what about this one? Diaper and beer. So diaper and beer, diaper and beer, diaper and beer, we have 3. And we want to check only diaper. How many person bought diaper? We have 1, 2, 3, 4. So 3 out of 4 transactions who have diaper, he or she will buy beer. So the confidence is 75%. Okay. So this is the association rule, and this is the frequent pattern. Okay, what is Itemset? It is a collection of items. Okay. Collection of one or more items. It can be one, which is k equals to 1, or it can be more than 1. K can be 2, k can be 3, 4, and so on. What is support? We have two kinds of support. We have absolute support. It is about the count of the items in the transaction. Okay. And the other is the relative support. This is the fraction of the items in the transaction. Maybe I can say from the overall transaction. So if we have the absolute support is 2, then the relative support will be the fraction. If we have 5 total transaction, then 2 out of 5. What is confidence? So let's suppose we have x and y, and we have this association. So we want to know what is how confidence that items y, item set y, appears when there is item set x. If the confidence is 100%, then it means we have a high confidence that x follows with y. If the confidence is low, then we have to check maybe the x is not followed by y. So we need to check the frequent item set mining method. The frequent item set mining method, there are some methods a priori. It is the candidate generation and test approach. And there are some other methods improving the efficiency of a priori, like the FP code, ECLAT. But I think we will just learn the very basic, which is the a priori approach. A priori approach. What is the meaning by a priori? It is a candidate generation and test approach. The condition is any subset of a frequent item set must be frequent. This is the keyword. Any subset. So the subset of frequent item set must be frequent. If you see that A and B and C. I have this set. If A, B, C is frequent, then AB is frequent, AC is frequent, BC is frequent, and then A is frequent, B is frequent, and C is also frequent. Okay. So if this set is frequent, so this is the subset. So all subset is also frequent. So if a certain item set is frequent, its subset is also frequent. So if beer diaper X is frequent, then the subset, which is beer and diaper, is frequent. You can check from this proposition. I'm not sure if you still remember. You learn in the Pyongyang Swap. In the Pyongyang Swap, there will be this law, the Morgan's law. If A, B is true, what is the correct one? B to A is true, or negation of A, negation B is true, or negation of B, negation A is true. So based on the Morgan's law, if A, B is true, then this proposition is true. So the a priori pruning principle is like this proposition. If a certain item set is not frequent, then its superset is not frequent. Okay. If I mentioned before, A, B, C is frequent, then A and B frequent, B and C frequent, A and C frequent, A frequent, B frequent, and C frequent. Okay. But what is the opposite one? The opposite is if this one is not frequent, then this one also is not frequent. Okay, that's the meaning by this proposition. So we will use this a priori pruning principle if there is any item set in which is infrequent. Infrequent is not frequent. So infrequent is not frequent. Then its superset should not be generated. The superset should not be tested. So this has been proposed by Agrawal in 1994. So the method is something like this one. Let's just see the example. Now I have this TDB. We call it, this is the transactional DB. Okay. This is the transactional DB. And I have the minimum support 0.5. And the minimum confidence is 0.7. So the first step is to find the frequent item sets. The transaction ID 10 is ACD, transaction ID 20 is BCE, 30 is ABCE, 40 is BE. If we have the minimum support is 0.5, then how many transactions do we have? 1, 2, 3, 4. 50% from 4. 0.5 multiplied by 4. Okay, 0.5 multiplied by 4, it means 2. Okay. Then the support with equals to 2 will be included for our analysis as the frequent value. So the first we will scan how many we have k equals to 1. When k equals to 1, so we will check the item A, B, C, D, E. Okay, there are 2 of A, there are 3 of B, there are 3 of C, we have only 1 of D, and we have 3 of E. The minimum support should be 2. Then we will eliminate D because it is only 1. The minimum support requires at least 2. So we will have the first, we call this is candidate. C1 is the candidate 1. After we scan this one, we will have this L1. So the L1 is the list that follows this group. So we have only A, B, C, and E that can be done for further analysis. Okay, we delete this one. Now we will move to the k equals to 2. When we move to k equals to 2, we will select the possibility. The possibility is we can combine A and B. We can combine A and C. Okay, we can combine A and E. We can combine B, C, P, E, and C. So this is the k equals to 2. Now we need to scan again. This scanning, we will check the frequency of the support. What is the support? Okay, I can see that AB is 1, AC is 2, AE is 1, BC is 2, PE is 3, BC is 2. We know that the support minimum equals to 2. Then we will remove when the support equals to 1. We will delete it. The candidate 2, now it becomes L2. We only select the item set which is equal or greater than the support minimum. After we have the L2, now we will check the next, which is k equals to 3. So we will check until the maximum k that we can get. So from this one, we can check that the possible is BCE. Okay. Maybe you will have questions. Why BCE only? Why not ACE? Why not ABC? Okay. So if you can see, what we learned before is if the subset is not frequent, then the superset is not frequent. Okay. In order to get the BCE, then we will check for every possible frequent. B and C. Is it frequent? Okay. B and E. Is it frequent? Okay. And then C and E. Is it frequent? Yes. Then we can consider this as a item. Let's see another possibility with k equals to 3. Why we do not choose A, C, and E? We need to have all the subsets frequent. Let's see. AC is frequent. Okay. AE, is it frequent? No. Okay. Because AE is not frequent, then we don't need to choose ACE. So let's see another example. Why we don't choose A, B, E? Okay. Now we can see AB. Is it frequent? No. Then we can just remove AB. Okay. That's the meaning. So we will just use the BCE. So the BCA support is 2. So this will be the frequent answer. Okay. This is the final frequent item set. So this is the final frequent item set for k equals to 1, k equals to 2, and k equals to 3. We cannot scan more. Even though we have the A, B, C, E when k equals to 4, but this is not our case because the minimum support requires at least 2. Meanwhile, we have only 1. So the step number 2 is to find the association rule. In the association rule, as I mentioned to you, we need to start when the k equals to 2 to find the association between two item sets. So we already have the L1 when the k equals to 1, L2 when the k equals to 2, and L3 when the k equals to 3. So we can find any possibility. We can find any possibility when L2. So we have this AC, CA, and then we have the second BC. We will check the B to C and C to B. And we will check BE, EP, and we will check CE, P. Okay. We know that this already satisfies the support. Okay. So we just need to check the confidence. Here is the confidence. A and C. So we will check the support count of AC, which is 2. And then it will be divided with the support count of A. What is support count of A? It is 2. And we will have 1. What about CA? So CA is the support of AC, which is 2. And we want to check with the frequency of C. Frequency of C is 3. 2 out of 3. And it is 0.67. What is the requirement of the minimum confidence? It is 0.7. And it is not included because it is below 0.7. So you can check for all the confidence, and the blue colors are the association rule that fits with the minimum confidence. So this is when the k equals to 2. What is next? So we need to check when the k equals to 3. When k equals to 3, we can see from the L3. Okay, the L3, we have BCE. So we will check for every possibility BCE, BEC, CEP, and then we have B goes to C and E, C goes to B and E, and then E goes to B and. So we can calculate confidence, and we will select only the confidence which is higher than 0.7. So this blue color is the confidence higher than 0.7. Then you will get the final association rules. Okay. Yeah, just for the hint on the mid exam, there will be one problem about this. Okay, so make sure that you understand how to calculate the support and the confidence. So the a priori algorithm, it can be seen like this one. The candidate item set of size k is the C. Okay. Size k means the k equals to 1, k equals to 2, k equals to 3. And the frequent item set is in the L. It is a little bit complex to understand this pseudocode. Yeah. If you want to look at this pseudocode, okay. But let's see just an example how we can implement this a priori. How we can generate the candidates. How we can make the C. Okay. You can self-joining the LK. What is self-joining? If you have A, B, C, E, then you can just join them. A and B, okay. A and C, so this is just self-joining. And then B and C, and then B and E, okay. And then A and E, and so on. Okay, so there will be many combinations. So this is the self-joining. And after you do this self-joining, you need to prune. Prune means delete. Okay. So delete means, as you know before, let's say we have L3. We have A, B, C, A, B, D, A, C, D, A, C, E, and B, C, D. So when you do the self-joining, yeah, you can have like this combination. So the combination can be A, B, C, D for the next candidate. Okay. Or it can be A, C, D, E. Okay. Or it can be okay, maybe these two. Okay, this is the self-joining. You can find the combination from this candidate. And then next we will do pruning. Why pruning? Yeah, it will be removed because there is no ADE in the L3. Okay. As you know, if its subset is not frequent, then its superset is also not frequent. So because there is no ADE, okay, there is no ADE, then we will not create ACD. Okay, so we can remove it. So the candidate is only one, which is ABCD. That's the meaning with the previous example. Okay, let's see another example. We have this transactional data. We have minimum support 0.2 and we have minimum confidence 0.7. Find the frequent item set and then find the association rule. 0.2. What is it? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0.2 multiplied by 9. It is 1.8. It's difficult to have 1.8. Maybe we can just round it. Okay, 2. So it means the support count at least there are 2. So these are the items, okay, I1, I2, I5, and so on. So this is the step. First, we will create the C1. C1 means we want to get the candidate. Okay, we want to get the candidate that follows the support count based on the minimum support. So you can check I1, there are 6. So you can check 1, 2, 3, 4, 5, 6, and so on. So those are the frequent. Here, if you want to check the candidate, okay, for all, let's say you want to calculate also the, we have okay, I think every of this item are fit with the minimum support. So we have I1, I2, I3, I4, I5 as the L1 or the frequent items. And then we will check with the K equals to 2. So we will find the every possibility. Oh, sorry, this one. We will find for every possibility. You can generate the C2 or the candidate 2. And then, we will check the support count. I1 and I2, there are 4. I1 and I3, there are 4. I1 and I4, there is only 1. And so on. So because we have the minimum support 0.2, let's say we want to select which is equal to 2 and higher. So we will remove this one. We remove this one. We remove this one. We remove this one. So the frequent item set will be this. And from this, we can generate the C3, the candidate 3. And the candidate 3, I1, I2, I3, I1, I4, I2, I5. You can check based on this combination. Why there's no I1, I2, I4? Here there's I2, I4. Why there is no I1, I2, I4? Because this is not frequent. I1 and I4 is not frequent. Then we can remove the candidate. So the candidate will be only 2. Then we can do the support count 2 and 2. So this is the frequent item sets. And we can calculate the association. We can calculate the confidence. You can have the confidence when the K equals to 2. You can have the confidence when K equals to 3. Okay. And then check where is the association which have confidence more than 0.7. Okay, this is not, this is not, this is not. Okay, so the confidence 0.7. No, no, no. So most of the confidence in the this one okay. This one okay. This one okay. Okay, so only 3 when the K equals to 2, and there are 2 when the K equals to 3. Okay. Okay. So what is a priori algorithm? You already learned this a priori algorithm. And if there is any item set which is infrequent, is superset should not be generated or tested. True or false? It is true. Okay. Okay. Any questions, comments?